Day 619 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1266, minimum time visiting all points. The difficulty level is easy, but don't worry because you already know we're going to keep the solution as simple and easy to understand as well. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. On a 2D plane, there are endpoints where integer coordinates, points of i's equal to xi, yi. Return the minimum time in seconds to visit all the points in order given by points. You can move according to these rules. In 1 second, you can either move vertically by 1 unit, move horizontally by 1 unit, or move diagonally, meaning square root to the second units. In other words, move 1 unit vertically, then 1 unit horizontally in 1 second. You have to visit the points in the same order as they appear in the array. You are allowed to pass through points that appear later in the order, but these do not count as visits. All right, y'all, so let's break this down one step further by taking a look at these examples. So in example 1, we have our input points equals a 2D array of integers. First array 1, 1, or the first point is 1, 1, then 3, 4, then -1, 0. So these are the 3 points we need to reach. Output is 7. That means it took 7 seconds to reach all 3 of these points, right? So let's see how we got there. So it says one optimal path is 1, 1. So let's see if we can find 1, 1. Okay, 1, 1 is right here. Boom. Then we go to 2, 2. Boom. Then we go to 3, 3. Boom. Then from 3, 3, we go to 3, 4. Boom. So we started at 1, 1. So that's 1 point we've checked off. Now we're at 3, 4. 3, 4 is right here. That's the second point we've checked off, but we're not done yet, right? So because we still need to reach -1, 0. So then we come down here to 2, 3, then we come here to 1, 2, then we come here to 0, 1, then we come here to -1, 0, and that's the last point. And now we have reached all 3 of these points by following these rules right here. Boom. And in total, that took 1, 2, 3, 4, 5, 6, or excuse me. So these points, sorry, I guess each point doesn't count as a second, or this would be 1 second. Boom. Then this would be 2 seconds. Then this would be 3. Then this would be 4. Then this would be 5. Then this would be 6. Then this would be 7. Boom. So we're not really counting the points. It's more of we're counting the edges. 1, 2, 3, 4, 5, 6, 7. Yeah. So more as looking at the edge. Each edge is 1 second. In total, it took 7 seconds, y'all. Boom. So it took time from 1, 1 to 3, 4. So that's from here to here. That took 3 seconds. And then from 3, 4 to here, that took 4 seconds. Boom. So in total, it took 7 seconds. Boom. So just in case that didn't make sense, let's take a look at example 2. Example 2, same principles apply. So in example 2, our input points equals a 2D array of points, so integers. First point is 3, 2. Next point is -2, 2. So there's only 2 points, and this time it'll take 5 seconds. Boom. So now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution is not that difficult at all. Now, first thing we're going to do is we're going to create a helper function that calculates the minimum time required to move from point 1 to point 2. Since diagonal movement is allowed, the time needed is the maximum of the horizontal vertical difference. So we're going to come right here. I'm going to say func distance, open up the parentheses. We're going to say underscore P1 colon square bracket int. Come outside of that, we're going to say comma underscore P2 colon, come outside of that square bracket, that's going to be an integer. And then we're going to come outside of these parentheses and we are going to return an integer. Boom, just like this. Open up the brackets. Now, first thing we're going to do, we're going to say let distance x equal ABS, open up the parentheses, P2 square bracket 0, come outside of that, minus P1 square bracket 0. Boom. Then we're going to come underneath that and we're going to say let distance y equal ABS, and this ABS is just the absolute value, right? Or it's how many points away it is, or how many units away from zero it is, or numbers away from zero it is. And this time we're going to say P2 square bracket 1, come outside of that, we're going to say minus P1 square bracket 1. Boom. Then we're going to come underneath that. We're going to return, return max, open up the parentheses, distance x, comma, distance y. Boom, just like that. Now we're going to come underneath this and we're going to start from the first point. So we're going to declare a variable called P1 and we're going to set that equal to points dot first exclamation point. Boom. Then we're going to come underneath that and we're going to accumulate the total time to visit all points by creating a variable called total. We'll set that equal to 0 just to start. Boom. Then we're going to iterate through each subsequent point by saying for P2 in points dot suffix, open up the parentheses, from colon 1, come outside of that, open up the brackets, and we're going to add the time required to move from the previous point to the current point. So we're going to say total plus equals distance, open up the parentheses, P1 comma P2. Boom. Then we're going to update the previous point by coming underneath that. We're going to say P1 equals P2. And then we're going to return the total time required to visit all points by coming underneath that. And we're going to say return total. Boom, y'all. That should be all she wrote. So let's give it a run. Make sure it runs properly before we submit it. Okay, it's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see, and look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.